Please welcome developer advocate, Steve Bazyl.
Hi, everyone. Thanks for coming today. My name is Stephen Bazyl. I'm a developer advocate out of Mountain View, California, where I mostly work with developers who are building business applications, and I help them integrate their application with Google Apps. Today, we're going to talk about some of the newer features and APIs that have been added to Google Apps over the past 6 months or so, and talk a little bit about where the direction that we're going with our APIs. Just a quick question. Who here uses Google Apps? Just raise your hand if you do. OK, most of you. That's good. And who here, are there any resellers of Google Apps? Just raise your hand if you're a reseller. OK, just one. All right. We need more of those. So today, we're going to look at, again, talk a little bit about Google Apps, just for those who don't use it, may not be as familiar. Talk about our Google Data Protocol, kind of where we've been in the past. Take a look at the direction that we're going with our newer APIs. I'm going to switch gears a little bit after that and talk about a technology called AppScript, which is a very little-known feature of Google Apps, but one that I think is actually pretty cool. We have another API that we launched fairly recent called the Picker API, which is a UI component you can use in your site. Do some demos of all this, and then talk about some of the distribution opportunities if you're a developer building a web application that you want to sell to Google Apps users. So for those who aren't familiar with Google Apps, it is our online communication and collaboration suite. This includes things like Gmail, Contacts, Calendar, Google Sites, Talk, and so on. And these are all available for organizations and businesses, also very popular among educational institutions. And it's just a way for people to run their businesses and organizations in the cloud. It's very popular. We have over 4 million businesses that use Google Apps. We sign up about 5,000 new businesses every day, and there are about 40 million active users. So we have a lot of large organizations, but it's extremely popular among small businesses around the world. So Google Apps is part of our vision for how we think businesses should be running software. And that's 100% of their business, 100% of their applications running in the cloud on the web. And we think Google Apps plays an important part of that. Everyone needs communication and collaboration tools like email, documentation, spreadsheets, and so on. But of course, that's not enough. People need more. They need accounting, finance, project management, countless applications that are specific to different types of industries. And those might be applications that people build themselves. And we have hosting options like App Engine to help do that. But they may be third-party applications that are developed and sold. And we have our Google Apps Marketplace to help customers of Google Apps discover those applications and enable them for their users. So all of these applications do need to have some common infrastructure to tie them together to make for a great user experience. Things like identity to let users switch between apps easily. And of course, we expect that they're built with modern web technologies and available for users using modern browsers like Chrome, smartphones like Android or iOS, and netbooks like Chrome OS. So how do people get there, right? Well, Google Apps has a lot of APIs that are part of the suite of what we call Google Apps. For every one of those individual apps, like Gmail, Calendar, and Contacts, there's a corresponding data API that developers can use to access that information. If you're building an application, we have App Engine, which has some features that integrate nicely with Google Apps. And we also have AppScript. And AppScript is a JavaScript engine that runs in the cloud, server-side JavaScript, running on Google's infrastructure. It's a very cool technology, not very well known. But again, I'll show you how you can use it. And it's a great tool for simple workflow and automation. But people have built some really interesting apps using this technology. And the third leg of this are UI extensions. There's a technology called Opensocial, that allows you to build gadgets. These are small bits of HTML and JavaScript that you can use and embed inside Google Apps. And so you can find gadgets inside Google Calendar on the sidebar. You can actually do event calendars that appear on a particular day. Sites supports gadgets as well, and Gmail does as well via what we call contextual gadgets. And these are gadgets that actually trigger based on the content of a particular message. Really useful for CRM, customer relationship management apps, project management, and we see a lot of developers starting to pick this up. So that's that's the overview of Google Apps. I want to talk about the data API portion of that first. Who here has ever used the Google Data Protocol or any of the GData APIs? Okay, so a handful. Okay, so of those of you who raised your hand, how many feel that they really understand the GData protocol? Okay, no one. Yeah, I don't either. It's complicated. So why is GData so hard? Well, the first part is, when we built this, we gave developers a choice. Well, you can use HTTP or HTTPS. And keep in mind, these are RESTful protocols. They're just built to run over the web as it is built today. The authentication picture is pretty complicated. A couple years ago, we started with client login, which is a way to exchange a username and a password for a token. We added authsub, which is a precursor to what is now the more standard way of doing it, called OAuth. And there's an emerging standard, OAuth 2, which is gaining popularity. And there was a talk earlier today that I hope you got the opportunity to attend. Right, and then the data formats XML. Right? Of course, XML doesn't really tell you all that much. You still need to have a schema on top of it. So the people who developed Google Data decided to extend the Atom publishing protocol, also mix in some OpenSearch, and then layered another schema on top of it. And that made for a huge surface area that developers had to understand in order to use these APIs. This is an example. I just ran this query the other day. This is the output from my calendar. So about 40 lines of XML here. I don't expect any of you to be able to read this. But the interesting thing is that on this screen of 40 lines of XML, there's not a single calendar entry on it. This is all just metadata about the calendar feed itself, but no useful information for my application. Right? I have to go to the next page of information in order to get to what I want. Right? This is really hard for people to understand. Another problem with our APIs is just more of an internal issue with how they were built, but it was hard to get feature consistency across all these different APIs. One that was particularly bad was our domain management APIs. These are the things that allow domain administrators to script management of Google Apps. And while it has the same protocol, and it looks very similar to other APIs like Calendar and Docs, the feature set and the behaviors are radically different. And there's it's just very difficult for developers using multiple APIs to navigate which API supports which particular feature set. So a couple challenges that we're out there trying to solve. One is reducing the amount of knowledge that you guys need to understand in order to use our APIs. We already talked about how verbose that data is. The fact that XML itself is sometimes difficult depending on the language you're in. It's a very rich format, has a lot of flexibility, but that flexibility comes at a cost. It's just a very difficult format to work with in most languages. Another issue has been our client libraries. For those of you who have been using PHP with the GData libraries will probably understand that it's sometimes a lag behind in terms of features. If you've done Ruby and you tried to use the Google Data protocols, you've basically been on your own this entire time. There's been no library support for it. And we already talked about inconsistent feature sets. So how are the new APIs built? Well, we simplified. So right now, you only have one choice. Everything has to be over HTTPS. Everything is secure by default. No choice. Authentication is also simplified. Client login and authsub are effectively deprecated. We're now just using OAuth in the new APIs. And we're no longer tied to that complex set of XML specifications. The new stack actually gives us a lot of flexibility to support multiple formats. JSON is our preferred format now for the new APIs, but if we want to, we can very easily return back other formats like simple XML, CSV, or whatever new format we decide to use. Effectively, it's simpler than that. The only things you need to know about with the new APIs, HTTPS, OAuth 2, and JSON. Much simpler. We have, by virtue of this new stack and new infrastructure we're using, a lot more consistency in our APIs. Whenever we add a new feature, say partial response and partial updates, which I'll talk about in just a moment, we can roll that out to all of our APIs that are using this new infrastructure at the same time. When we add things like batching, again, that's a feature that we can roll out to all of our APIs very quickly, whereas previously it would take sometimes months or even years for different APIs to catch up. So it's a lot easier for developers who are using multiple APIs to work efficiently across them. So what APIs actually use this infrastructure? Well, there's a lot of the new ones. A lot of the general Google APIs, like Google+, the prediction API, storage, are all built on this new infrastructure. When we talk about the APIs that are part of Google Apps, right now there's only one, and that's the Task API, which was launched back in May at Google I/O. We are working on some other ones. There is a new version of Calendar, which is due very soon, hopefully within days. But we'll see when that actually happens. And other APIs like Docs and Contacts will be updated eventually. I can't give you a date, but we're working on those. And it just comes whenever they're due for their next major version, they'll be built onto this new infrastructure, and you'll have all these benefits available. So I'm going to go through some of the examples, and these are all going to be with the Task API. So you can see here it's a much simpler data format. It's JSON. It's really easy to use. On most languages, it maps to basic data structures like maps and lists. And here you can see a response, which is my task list. And there's only a few attributes that we throw in there that have any special meaning. We give it a kind, which is basically an object type. Tells you what type of data it is. E-tags are versions. We use this for caching, and we also use it for concurrency control. The next page token is a cursor for retrieving subsequent pages of results when you have a lot of entries. And items, in this case, is just a collection of different tasks. And then each one of those would have the same attributes as well as those attributes that are specific to the type of data. So in this case, a task has a title. You can look at this and you can understand it pretty easily, something that you didn't have with the old GData protocols. So one feature I want to talk about, which is pretty useful, it's a little bit of an advanced feature, but something that's really important, particularly for people that are building mobile applications or where they want to use these APIs in a browser, and the user may not have a lot of bandwidth. And it's a feature called partial response that allows you to tell the server which attributes you want it to return back. So if you have a very complex data structure, but you only need 3 or 4 attributes, you can just tell it in the request by specifying that fields parameter which attributes you want to return. And you can actually, so notation you can use to specify even the attributes inside nested objects. So in this case, we just want the ID and the title of all of my tasks. It's a really useful feature. There's another case where it's very valuable, which is when you're updating an object. If you are creating a new item, right, you already know what the state of the object is, right? And by default, our protocol will just echo that back to you as part of the response. Most of the time, the only thing that you need to know is the fact that it was created and a few calculated attributes, like what the ID of that object is and what its e-tag is. So rather than rather than have the server give you back the full response, you can just have it give it back those attributes which have changed as a result of you modifying that object. Similarly, if you're updating something, you know what the final state is, so all you need back is the e tag. And that will just tell you that the next time you do it, tell you that make sure that you have the correct version of that object. So you can save a lot of bandwidth by being a little thoughtful as to which attributes you actually need back from the API. So just like you can limit what you get back, you can also limit what you send. And using the patch verb, you can just send those attributes which your application is changing. Normally in RESTful APIs, the contract is that you have to send the entire object. This is an extension that allows you to just send deltas of attributes which your application modifies. Get a great way to save data, particularly when you have one of the larger objects in your API. Kind of a cool feature of all this new infrastructure is the discovery service. So all of these APIs built in this new style have what we call a discovery document, which is basically a JSON document that describes all of the features of that API, all of the methods, the URLs, the verbs, API parameters, what the response looks like, the schema. And it's actually just another API that you can go query. This allows us to build some really nice tools. And one of my favorites is what we call our APIs Explorer. And I'm actually just going to switch over to that and give you a little idea of what it looks like. And so this is built on top of our discovery service. And this really handy tool that you can see all of the different APIs that use this. One I want to focus on here is the tasks API. You can see the versions, and then all of the different methods that we can invoke. And since I have to access my task list, I can switch over to private access so it knows my data. That's just using OAuth. And let's just create a task here. So I'm going to use this. There's a special notation for this part, the default task list. And let's see here. Add a request body. I will add a title to say do something. And now we can execute. Oops. Or I could close my dialog first and then execute. So basically what it is I just added a task and we can see the response back from the server. This is a really handy tool if you're just getting started on one of our APIs. You can actually go here, explore the API, learn all of its methods, run them with sample data, and it will tell you what's required and what's optional. And it has links to the documentation as well. But you can pretty much learn an entire API before you write a single line of code. Really handy tool. So another advantage that this discovery service gives us is the ability to provide somewhat generic libraries. These are libraries that takes advantage of code generation to generate typed objects for languages like Java and .NET. And in cases where we're on a more dynamic language, say Python or PHP or Ruby, we can just use simple hashes and data structures to represent the data from our servers. You can see here's just two examples of the task API on Java and PHP. So here you can see in Java, it looks fairly clean Java code. You have tasks as a collection. You can iterate over it, view an individual task, and get out its attributes. The code looks nearly identical on PHP. Just in this case, we don't actually have strongly typed objects to work with, so we just treat everything as just a hash table. Another kind of cool feature of the new API infrastructure is the API console. And again, I'm just going to switch over and show you what that looks like. So this is basically a way for developers to manage their projects that they're using in Google with our APIs. And you can see here which APIs that you've activated for a particular project. In this case, I'm mostly interested here in the task API. But mostly what you use this for, my expired session, is controlling things like API access. So all of our APIs use OAuth and OAuth 2. In this case, I can manage my application's client ID and its secret that I use for OAuth. I can get reports on API usage. In this case, I don't have any data on here, but if this was a real project, I'd have a nice chart that showed me all of my traffic, how many requests I'm making. And I could also manage my quotas. So a lot of these APIs do have rate limits, but I can manage it here, and if I need to set up any sort of additional controls, if I want to limit it to certain IP addresses, or limit how much an individual user can use for that API, I can control all that here. And this is something that all of the new APIs are integrated into this console, and it's just really a handy tool. So those are the new APIs. So again, for Google Apps, we're a little bit behind on getting our APIs onto this new infrastructure. So far, we have just the one with tasks, but we are working to get all of our APIs into this. So keep an eye on our blogs, and if you are using these APIs or thinking about them, it's a lot easier than what it's been in the past. So I want to switch over to AppScript. Has anyone here actually used AppScript before? All right, so 3, 4, 5. So okay, no, there's actually, okay, there's more. Okay, there's probably about 10 or so. It's kind of what I expected. It's not a feature that a lot of people are aware of, but it's, I think, very cool. So for those who've never heard of it or haven't used it yet, it is a JavaScript engine. This is server-side JavaScript. It runs on our infrastructure. It's really intended for workflow and automation, and it has a ton of APIs that you can use to integrate various Google services together. And you could also integrate with third-party services. And being that this is a server-side cloud JavaScript engine, you actually do all your development in the cloud as well. It uses an online editor and an online debugger for editing your JavaScript. Mentioned it has a ton of APIs. You can script interactions with Google Apps, pretty much all of our APIs, as well as some of the kind of more general Google APIs like the Finance API, prediction, translation. There's actually some user interface components, so you can actually do things with maps, charts. It actually has a built-in Google Web Toolkit user interface support and a graphical builder for constructing UIs. You're not limited to Google services. It actually has connectivity for calling SOAP services, or if you have RESTful APIs, you can just use the normal HTTP methods. And you can actually even call JDBC databases using a technology called Secure Data Connector. And a whole bunch of utilities. One actually just launched today was the locking service, which gives you better concurrency controls if you have a script that's being used by a lot of users. A lot of options. So I built a really simple demo. I would say very, very simple here. This is just a mortgage calculator, right? So it allows me to put in a request for a mortgage, and what it will do is calculate my payments, my amortization schedule, and email me a quote from the mortgage company. So if I submit this, what we'll see is we're going to get back a chart that shows my payments over time, interest versus principal, and it just sent me an email. And actually just ran this earlier just to get this. You can see what the email looks like, and it has an attached PDF. Right? And this PDF is this quote, and it's got all my values filled in. So this is all basically done in about 100 lines of JavaScript. And you can just see it here, actually. I'm not going to show you all this, but you can see it's 109 lines. So you built a nice little UI, builds a chart, sends an email, customizes a template, 100 lines of JavaScript, not too bad. Probably could have made it a little simpler if I wanted to. So let's actually see how that is built. So the first service I want to talk about is a service in AppScript called the document app. And what this gives you is full access to for manipulating a Google Doc, so our word processor in Google Apps. And this is just a screenshot of the template. The service allows you to create documents very easily. Just say document app.create, and that will give you a new blank document that you can work with. You can certainly open documents. And then once you have a document, you actually have access to the full structure of that. So you can work with the body. You can set and read or write headers and footers, create lists, tables, add images. Basically, it's programmatic access to a word processor. And so you can use this, in the case of my example, for doing templates. And so this is just a generic method that I'm using in that example for treating a doc as a template. And I can just pass in a doc ID and a hash of values, key value pairs for my search and replace. And you can see here, it's fairly simple. The first thing we do is we make a copy of our template that we can work with. And then we open that up. We get the body of that document. That's the get active section. And then we just iterate through the values in our hash. We look for the keys that we want to replace, update the text, and now we have this completed document. So pretty easy. You can take this method, stick it in a library, and use it for processing a template of any type. The other service that we used is a charting service. And these are just some screenshots of different types of charts that you can use with the chart API in AppScript. Using the API is pretty simple. It's really done in 2 steps. The first thing you have to do is assemble your data. This is not the code from the demo. It's just a little bit easier to understand example. But basically, the data table is just a set of rows and columns. So we define our columns. We give them some labels. It's the add column calls. Then we can go through and add our rows. We just takes an array of values. And at the end, we call build. This is all using a builder pattern, which is becoming quite popular in AppScript. You'll see this a lot. So now we have a data table. So we have this basically a grid of data. Now we can build a chart. And there are different builders for different types of charts. In this example here, we're going to build a column chart. We give it the data table that we just created. And then we can customize it. We can customize how it's displayed, set the colors, give it a size, add labels to the different axes, build it. Now we have a chart object. And that chart object we can use in a whole bunch of different ways. In the example I showed you earlier, we then took that value and embedded it in our UI. But we can also convert that into an image. And we can upload it to a Google site. We can send it in an email, stick it into a doc, pretty much anything that we want. The next piece I want to show you is the UI builder. This is actually kind of an experimental feature in Google in AppScript that allows you to do drag and drop construction of UIs. And that's actually how I had built the UI very quickly. I can actually show you. So this is the builder here, and so I can go in, and if I want, I can. It's a little hard to do with this resolution, and with part of the email or part of the UI being in Japanese, which I don't speak, but I can edit this, change our label, and I don't know which option is save. Maybe it's that one. I think I got it right. All right, so now if I actually went back to my demo, in theory, that updated. So just really an easy way to construct it. If you don't want to use the UI builder, it is pretty glitchy. I will say that. There's a few workarounds you have to do. But if you don't want to use the drag and drop method of building UIs, there's actually a fairly low-level API that's very similar to the Google Web Toolkit API. It gives you a lot of different widgets that you can use, different layouts, and you can construct a UI and then publish it as a web service. So this is actually the code for publishing that service. If you just want to make a web app out of AppScript, you just define a do-get method. And you could also do post, and any of the HTTP verbs. In this case, we want to display a UI, so we call the UI app service create application. We load our component that we designed in the UI builder, add it into the app, and return. And that is a web app in AppScript. Pretty easy. And if you want, you could actually just return. If you just want to show text, you can just do get return hello world, and you'll get a web page that returns hello world. It's really easy. So there's a third API I want to talk about, which is something that we launched probably about 3 months ago with very little fanfare. We didn't really blog about it. We didn't really announce anything about it. But it's, I think, a really cool API if you want to do some integration with Google Docs, but you don't want to have to do a lot of UI work. And it basically gives you the same UI that we use in a lot of our Google products for selecting documentation, like selecting docs if you want to attach a doc with email, if you want to pick photos from Picasa. That infrastructure in that UI is now packaged up into a widget that you can use in your applications. And I have a little demo of that, which I can show you. So it's really, really simple. We can work with Google Docs. If I want, I can pick the email that has my mortgage quote that we just generated earlier, and grant access to it. And what you see back is we actually get some thumbnails. It's a little hard to see you can see the thumbnails. We get thumbnails of preview images of the doc that we can access, along with icons, the titles. And you can see here this is the raw JSON that you get back. So you get a user callback that we'll talk about in a little bit. But you can see all the information that we got when I picked that doc. So we get the type, the last time it was edited, icons, thumbnails of all different sizes, and an access token at the bottom, which I will mention at the end is actually a really cool feature. But I want to show that again in a different context. So we can do documents, but we could also do Picasa photos. So I'm going to go, I had this really awesome trip where I got to play with river otters and sloths, and how about this picture of an armadillo, which I think is actually kind of a cool picture. So you can see all the thumbnails. We actually get the full-size image here, which we can't really see, but there's the hindquarters of an armadillo for you. But again, you get very similar information, get all of our thumbnail images, the full image as well. And you can even actually use this to upload if you want people to upload images, right? So this is the same thing, a different view that allows me to pick a file from my file system, upload it to Picasa, and then return that information back to my app. And it actually has some other features too. You can actually work with Google Maps. It works with image search and video search as well, all with the same UI. And you can fully customize how that UI works and which views you want to support for your application. So let's actually see how that looks from a code perspective. So it's pretty easy. First thing you have to do is just include some scripts. So you include our JS API. Say you want to load picker. The next thing you need to do is, whenever you want to display it, is just call a method to construct the particular views that you want. In this example here, we're building a picker that only supports Google Docs, and then we give it a callback. And that callback function is basically called whenever the user clicks or cancels, whenever the picker closes. And then based on the response, we can do something interesting with that data. In this case, we just are showing an alert message, or just appending a simple message to the doc. But your application can do a lot more with it. And you can actually use this. You can have a picker that supports several different views. And if you do that, then you get back, there'll be a tab on the left that users can pick if they want to, say, upload a doc or an image or a video. It's incredibly configurable. And that's it, though. That's all the code. To have that UI on your application, that was all the code you need to write. So one of the cool features with this is when you're using the Google Docs integration, it will actually generate an OAuth token that is valid only for that document and for a limited time. So basically for 24 hours. This is really useful because there's a lot of businesses that sometimes don't want to give you full access to all their documents. Right? There's a lot of sensitive information that they store in Google Docs, some intellectual property that they may be sensitive about. But using the picker, you can have integration with Google Docs and their doc list, but do it in a way that the user only has to give you piecemeal access, where they only have to give you read access to individual docs at their time of choosing, and in a way that is fairly safe because it will expire quickly. So you can think about if you have like a doc printing service, say you're an online printer, you don't need to read every document that somebody has. You really just care about the one that they're trying to print at that same time. Similar if you're doing document signing or anything like that, where you only need one-time access. And of course, it's localizable. We can pass additional parameters when we load that widget and specify whatever language we want to display that's appropriate for the user. So the last part I want to talk about is distribution. So if you are building web applications that you want to sell to Google Apps users, right? So you have all these great APIs available to you. You built an app, right? Of course, you need to get customers. And for that, we have the Google Apps Marketplace. The Apps Marketplace is not particularly new. It's actually been around for a year and a half or so. But we have been working on some new features for that, some things I want to point out. One is we're expanding the audience for who can buy applications from the marketplace. Up until recently, the marketplace was only available to Google Apps domain administrators. Right? So when you installed an application from there, you were basically installing it for all the users within your domain. And it's really handy for a lot of cases, but only one person out of that entire organization really had access to buy anything. And it's a good opportunity, but it's not great. Right? So what we did is started an experiment that allows individual users to go to the marketplace, install, purchase applications for their own use, and then share that out and to the rest of the organization so that more and more users can go in there. And it's an experiment right now. Probably about 20% of the domains actually have this feature turned on, and there's about a dozen applications that have this feature enabled. But it does give you an idea of where we're going. Basically, we want to make it very easy for you as application developers to reach as many customers as possible. We did start a staff picks section fairly recently. And this is just us as advocates and our product managers and engineers highlighting what we think are the best applications. So the challenge that we sent out there to the developer community is just build applications that really impress us. And if you do that, we will feature your application and hopefully drive a lot more business to you. And of course, we've been working on the searching, making it just a better opportunity for you as a developer. The requirements for getting in the marketplace are pretty simple. We have one requirement, which is single sign-on. That is just to make it really easy for users to switch between applications, just as they can switch between Gmail, Calendar, Contacts, and Docs without having to sign in every time. When you buy an app from the marketplace, you get that same ease of use and the same ability to switch between applications seamlessly. And we do that with OpenID. Hopefully you got to go to the talk earlier today about OpenID and OAuth and where those technologies are going. If not, I encourage you to watch it when it's available on streaming. And of course, single sign-on is great, but we really do encourage applications to find as many ways to integrate that provide value to users and help them be more productive. So just a quick recap, and then we'll take some questions or you go outside to the office hours. We do have this vision of 100% web. We do understand that Google Apps is only a small part of the solution. So we do need developers who are building web applications to fill in the gaps. And it's actually more surface area for you to build applications than there is for us. A lot of tools for you. Certainly all the apps APIs, tasks, contacts, calendar, and so on. we are working very hard to make these APIs a lot easier to use. So just be patient. You can use the current APIs. They're not quite as bad and as scary as I made them out to be. But if you do want to start looking towards the future, you can try it out with the Task API today. AppScript is a really cool tool if you're a Google Apps user. We're not quite to the point where AppScript is monetizable. So it's really, people do develop and distribute scripts, but there's not a lot in terms of IP protection. So it's not really a language you can use to build commercial apps yet, but something that we are aware of. And then you can do some really cool stuff with the Picker API, and we're going to look to find different ways of making these APIs more accessible to you as developers. A couple of resources. You can find our marketplace at google.com/enterprise marketplace. Our forums and documentation for the full set of Google Apps APIs is code.google.com/Google Apps. Our blog is at googleappsdeveloper.blogspot.com, and you will find articles that are both about all these different APIs. Sometimes we'll do new API announcements. We do a lot of guest posts from members of the community. There's been a lot of activity recently about AppScript on there. But we also talk about OAuth and OpenID as well. If you're on Twitter, a few of the members of the team, we have an official Twitter account for the team at Google Apps Dev. But you can also find Ryan Boyd, Scott Mcmullen, and myself on Twitter. And of course, Google+. I'm actually much more active on Google+ these days than Twitter. And you can find me at profiles at google.com/squirrel, or just search for Stephen Basil. And already been posting pictures of today on there. And yeah, it's fun. So that's about it. I will happily take questions. I actually don't have an earpiece for translation on. But I will happily take questions outside in the office hours. So thanks for coming, and enjoy the rest of the day.